Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's topic, while we are still exploring the knowledge area energy and change, we'll be looking at parallel circuits. Are we together? So let's quickly look at our lesson objectives. Right. These are the following things that we should achieve when this lesson ends. So when this lesson ends, we should be able to describe a parallel circuit, right? We should be able to describe what a parallel circuit looks like or what a parallel circuit is. Also, we need to be able to differentiate between a series and a parallel circuit. Not only that, we need to be able to explain that in a parallel circuit, the voltage is the same across each resistor that is connected in parallel in a circuit. Also, we need to be able to explain that the total current through the battery is equal to the sum of the currents through the resistors in parallel. And also, as I've said, that you need to be able to explain that the total current in the circuit increases as more resistors are added in parallel, right? All this information is found under the CAPS document on page 74. Now, moving on to our pre-knowledge, right? Which are the things that we have covered in the previous grades and also probably the same grade, and they lay a foundation to today's topic. So in grade 5, we talked about electric cells, right? We introduced the topic of electric cells. Then also electric cells was revisited in grade 6, right? And we also did our electric cells when in grade 9 as well. Also in grade 6, we did what? Mains electricity. Thereafter, we did national electricity in grade 7 and as well as the supply system. Then in grade 8, we talked of energy transfer in electrical systems and as well as series and parallel circuits, right? Were covered in grade 8. So now, without wasting time, let's move on to our baseline assessment, right? So here we're going to read through the questions. Then after that, I'm going to give you 5 minutes to answer these questions. Then after that, we shall mark together. So number 1 is saying, is an ammeter connected in series or parallel, and why? Number 2, what happens to the current in a series circuit when we add more resistors? Number 3, what is the unit of measurement for current? Then number 4, what happens to the current flowing through the battery when we add more resistors in series, right? So let's take 5 minutes to copy down these questions and answer them quickly. Then after that, we shall mark together. Welcome back, grade 9s. Now remember, if you want to send in your answers, questions, or any comments regarding this lesson, our WhatsApp interactive number is 079-578-2908, right? 079-578-2908, and I believe you can see it there at the bottom of the screen, right? So now, let's go through the solutions together, right? Number one is saying, is an ammeter connected in series or parallel, and why? Number two says, what happens to the current in a series circuit when we add more resistors? Number three, what is the unit of measurement for current? Number four, what happens to the current flowing through the battery when we add more resistors in series, right? So now, here are the solutions. Number one, an ammeter is a very low, has a very low resistance, right? That is the reason why it is connected in series. It has a very low resistance and it permits the flow of current. So it is connected in series. Then number two, the current will decrease, right? When more and more resistors are added in series, the current will decrease, right? Then number three, current is measured in units called amperes, right? They are measured in amperes. Then number four, when we add more resistors in series, the total resistance increases and hence the current decreases. Are we together? So now let's take a quick minute to copy down these corrections, and remember, do not forget to interact with us on our WhatsApp number on the screen, right? So let's take that quick minute to copy down corrections. Then after that, we shall sail together with this lesson. Welcome back again, grade 9s. Now I hope we had enough time to copy down these corrections, right? So let's move on with our lesson now. Starting off with the important terms that you are going to come across as we go through this lesson. Right, series circuit, right? Which is the topic that we were covering on the previous lesson, right? A series circuit is an electric circuit that only has one pathway for current to flow through, right? It only has one pathway for current to flow through. Then we have current, and current is the flow of electricity or the flow of charge through a conductor, right? A conductor that can be a wire as well, for example, right? Then we have ohm, and ohm is the unit of measurement used to measure for resistance. Then we have ammeter. Ammeter is an instrument for measuring electric current in the units amperes. Then we have parallel circuit, right, which is today's topic. So parallel circuit now is an electric circuit that has more than one pathway for the current to flow through, right? So this will be our focus for today, parallel circuit, right? We'll need to look at how a parallel circuit works, right? In terms of its voltage, in terms of current, in terms of resistance, comparing it to what? To series circuit, right? So parallel circuit is an electric circuit that has more than one pathway for the current to flow. Are we together? So now, a parallel circuit, as I've just alluded now, right? It is an electric circuit that has more than one pathway for the current to flow through. So if you think of a series circuit, right? A series circuit only has one pathway for the current to flow, right? And it flows without branching. So in this case, we're talking of a parallel circuit now that has more than one pathway for the current to flow. So in other words, we say that this circuit has branches for current to flow, right? More than one branch for the current to flow. So this is our example of a parallel circuit, right? So now, as we said even in our previous lesson, that the current flows from the negative terminal of the battery to the positive terminal of the battery, right? So when you look at this now, right, the current flow would be in this direction, right? It would be in this direction, but look at this now. When it reaches this point now, it can branch to this side, right? It can branch to this side, right? And also going through the whole circuit, and also it can move to this direction, right? Making these two light bulbs to be lit. Are we together? So it has more than one pathway for current to flow, right? As we can see now, it has branch 1 and branch 2 this side for current to flow, right? So therefore we say it is a parallel circuit, right? As compared to a series circuit that only has one pathway for current to flow. Are we together? So now, in most cases, our houses are using parallel circuit connections, right? So house circuits contain parallel circuits. This is why, right? This is because you can simply be able to switch off another branch while the other branch still receives current and also giving power to our appliances, right? So the parallel circuit will continue to operate even though one component may be open, may be removed or disconnected from the circuit. Now let's think of this, right? Sometimes you are chilling where? In the sitting room, right? In the sitting room, and you don't prefer your lights to be on so that you can watch the television, right? So the lights are off where? In the sitting room, whereas they are on where? In the kitchen or probably in the bathroom, right? That is the advantage of a parallel circuit. You can switch off what? One branch while the other branches are still receiving current, and we are still able to use our components in the house. Are we together? So now, only the open component will no longer continue to operate, right? So as I've just said now, when you switch off that light in the sitting room, right, only that part of what? Of the circuit and what? The light bulbs will not work, right? Because the current is cut off. But the others will still receive current and the light bulbs will be on in the other rooms of the house. Are we together? Looking at this example again, right? This is a parallel circuit, right? So current is moving in this direction, right? And also it can branch to this direction. It branches to this direction, right? And also it can continue to move in this direction where it can branch again to this direction, right? And also it can move to the other or the third light bulb, right? And also it branches in this manner. But look at this now, right? When one component is removed from the circuit, the other two light bulbs are still lit, right? They are still on, right? This is because of what? Current has many pathways to pass through, right? Unlike a series circuit where you remove one component and the whole circuit now is not operating. Right. So now, let's look at the advantages of a parallel circuit connection, right? The advantages are the more devices, and in these terms, we're talking of what? The resistors, right? The more resistors that are connected in parallel, they will not affect what? The current, meaning they will not decrease current. The more devices connected in parallel will lead to what? No decrease in current. And another advantage is that if one resistor breaks, the rest of the circuit will still continue to work. Are we together? So now looking at this is what I've been saying, right? Current has more than one pathway to flow through, right? So looking at this, when this current is flowing, it has many branches to flow, right? Hence, when you remove one component, current can still pass through to the other branch to make the other component work, right? So our example comes back here again, right? When you remove this light bulb from the circuit, the others are still on, right? They are still on because of what? There is more than one pathway provided in this whole circuit for current to flow through. But now, also, there are disadvantages to a parallel circuit, right? Looking at the disadvantages now, right? Current does not stay the same for the entire circuit, right? Current does not remain the same for the entire circuit, right? Because what? Energy is used up quicker. But how, right? As the total current increases, it means what? The electrons are moving faster and faster throughout the whole circuit, right? As the electrons now are moving faster and faster throughout the whole circuit, the wires now, or our conductors, they heat up, right? They become hotter, and as they become hotter, they can lead to a power surge. So what is the power surge now, right? So a power surge now is what? The receiving of electricity at about 110% above what the circuit can handle. Are we together? So that's what a power surge is. So a power surge results from what? When one component of a circuit is not working, then now the rest of the current needs to go through the other pathways, right? Or the other branches, carrying an overload of what? Of current in them, right? Because of what? The moving fast of electrons, which can lead to these conductors being more hot, right? And also can lead to hazards, right? Hazards such as fire, as well as what? As these conductors heat up and they receive an overload of electricity, right? So looking at this here, right? As current does not stay the same for the entire circuit, right? Energy is used up quicker and the total current increases in the circuit or the parallel circuit, right? So when one component is broken here, and remember, the electrons are moving at high speeds, right? As they're moving at high speeds, what? The conductors heat up. As they heat up now, they lead to some of the components also breaking. As they are breaking, the other branches of the circuit need to carry the current that was supposed to pass on the broken component, right? So this can lead to a power surge and hazards such as this one, where you have these conductors overheating, sparking, and also causing what? Fires. Are we together? Right. So now, since we know what a parallel circuit is and we know some of its advantages and disadvantages, right? Let's unpack a parallel circuit now one by one, right? Let's start with connecting cells in parallel, right? So when we connect cells in parallel, right, we connect them by connecting all the negative terminals together and all the positive terminals together. Now, if you think of a series circuit, right, a series circuit, we said that we connect the negative terminal of one cell to the positive terminal of the following cell. right? They follow one another in a linear form, right? But in a parallel circuit, it is completely different. We connect what? The same nodes together, right? We connect the same what? Terminals together. We connect positive terminals together and all the negative terminals together as well in such a way, right? Let's look at this example, right? So just to remind you of what of the symbols of a cell in a circuit. We said that the long arm is our positive terminal and the short arm is our negative terminal, right? So let's look at this now, right? This is a parallel connection of cells, right? So when you look at this, the negative terminal of this cell is connected to the negative terminal of the following cell. But how, right? Look at this. The wire is connected in such a way, right? And in this way, and in this way, right? When you look at this now, all the negative terminals, they are connected together, right? With a wire. And all the positive terminals, again, they are connected together in such a way, right? So this is a parallel connection of what? Of cells, right? As compared to what? A series circuit where you have such a connection, right? Where you have a negative terminal of one cell connected to the positive terminal of the following cell, right? So this one is of a series connection, right? But this one is a parallel connection. Are we together? So let's move on now, right? So we said that now, when cells of the same voltage are connected in parallel, the total voltage of the battery is the same as for one cell, right? When the cells of the same voltage are connected in parallel, the voltage of the battery is the same as for one cell. So meaning if you have what? 1.5 volts per cell here, right? So the total voltage will be as of the same cell, right? Will be 1.5 volts again. Are we together? That is one thing about what? Parallel connection of cells. Right. So now let's look at connecting resistors in parallel, right? So resistors can be connected in parallel in a circuit, right? So now, the voltage now when connect, the voltage is the same across each resistor connected in parallel, right? The voltage is the same across each resistor connected in parallel, right? So meaning what? V1 is equal to V2, N is equal to Vn, right? To the number of voltages, right? To the number of resistors, right? So now let's look at this example here, right? When you look at this battery, which provides what? Our current, right? It has what? 6 volts, right? When you're measuring voltage, it carries what? 6 volts. And when you look at these resistors, resistor 1 and resistor 2, they are of the same voltage as well, right? Each one is 6 volts, right? Resistor 1 is 6 volts and resistor 2 also is 6 volts, right? So it is the same across each resistor, and we're talking about what? The voltage here, right? The voltage is the same for across each resistor, right? So now, the total current through the battery is equal to the sum of the currents across each resistor in the parallel circuit, right? And provided that the resistors have equal resistance. Are we together? When you look at this the example, right? The total voltage here is the same again, right? We're looking at resistor 1 and also resistor 2, right? And as well as if they have the same resistance, the same what? Current passing through is the same for resistor 1 and resistor 2. Right. So also the total current in the circuit increases now with each and every resistor that is added in parallel, right? So when you look at this example here, how many resistors do we have? We have two, right? We have resistor 1 and resistor 2. And I'm saying now the total current in the circuit increases with each resistor that is added in parallel, right? But now, when you try to compare these to a series circuit, in a series circuit, the more and more resistors that are added in the circuit, what is going to happen? The current is going to decrease. But in a parallel circuit, the more what? The current increases with each and every resistor that is added in parallel, right? So when you look at this, right? Resistor 1, right? When we add resistor 2 now, the current also increases in the circuit, right? The same goes for this example again. We have resistor 1, 2, and 3, right? When you add resistor 2 from on top of 1, the current increases, right? When you add resistor 3, also the current increases. Are we together? So let's look at this now, right? To dwell more on the advantages of a parallel circuit, right? Look at this, right? Current easily flows to resistor 1, right? But because of another pathway, current also easily flows to resistor 2, right? And because of another pathway, current easily flows to resistor 3 again, right? And our advantage is, as we've said, if you can switch off resistor 1, 2 and 3 can still work. If you switch off resistor 2, 1 and 3 can still work. And as well as if you can switch off or it becomes broken, resistor 3, 1 and 2 can still work, right? Because of the pathways provided by the circuit. Right. Now I want us to talk about current in a parallel circuit, right? So in a parallel circuit, the electric current splits, right? By splitting, we mean that it divides amongst what? The pathways provided by the circuit, right? And also we can measure the strength of the current in every branch of the parallel connection, right? So when you look at this, this is a parallel circuit as well, right? And we can measure the strength of current in every branch of the parallel connection, right? Right. Looking at ammeter 1, ammeter 1 is measuring what? Branch 1, right? And also ammeter 2 is measuring branch 2. Then ammeter 3 is measuring what? Branch 3 as well, right? And the current now is shared amongst what? It is split amongst what? The pathways of the circuit, meaning current flows through here, right? And also it flows through this side. Are we together? Right. So now let's quickly test ourselves in terms of how far we understand by writing activity 1, right? So number 1 says, what do we know about the total current through the battery in a circuit that has resistors connected in parallel? Number 2, what do we know about the total voltage across the battery of a circuit with resistors connected in parallel? Then number 2, list 2 advantages of a parallel circuit connection. So now I'm going to give you 4 minutes to complete this activity, and please do not forget to send in those answers, questions, or any comments on the WhatsApp number on the screen. Let's meet again after 4 minutes. Welcome back, grade 9s. Now we are going to look at the solutions together. Right. Number 1 says, what do we know about the total current through the battery in a circuit that has the resistors connected in parallel? Right? So the answer is that the total current through the battery is equal to the sum of the currents through the resistors. Then number 2, what do we know about the voltage across the battery of a circuit with resistors connected in parallel? Right? The answer is the voltage is the same across each resistor connected in parallel and across the battery. Number 3, list 2 advantages of a parallel circuit connection, right? Remember them? One advantage is that the more devices connected in parallel does not decrease the current. Then also, if one component is broken, the rest of the circuit can continue to operate, right? That's all for our activity 1. So let's quickly take another minute to copy down corrections. Then after that, we shall continue together with our lesson. Welcome back again, grade 9s. Now let's move on with our lesson. So now, let's kind of compare between series and parallel circuits, right? Let's look at the differences between series and parallel circuits so that we are able to distinguish between the two, right? So now, we have a table here of series and parallel circuits that we're going to use to compare, right? So in a series circuit, right, the same amount of current flows through all the components, right? That's what happens in a series circuit. Whereas in a parallel circuit now, right, the current flowing through each component combines to form the current flow through the source, which is our battery, right? The current flowing through each component combines to form the current flow through the source of current. In a series circuit as well, right? The components are arranged in a line, right? They follow one another. Whereas in a parallel circuit, the components are arranged parallel to each other, right? Also in a series circuit, when the resistors are put, right, the voltage across each resistor is different even though the current flow is the same through all of them. But in a parallel circuit, right, in a parallel circuit, when the resistors are put, the voltage across each of the resistors is the same, right? Even the polarities are the same. Right. Also, in a series circuit, right, if one component breaks down, the whole circuit will burn out, right? The whole circuit will not continue to work. But in a parallel circuit, other components will continue to function even if one component breaks down, right? Because each has its own independent circuit or pathway, right? So in picture form, right, just to emphasize what we're talking about, these are the differences between series and parallel circuit, right? So if you look at this, in a series circuit, there is only one pathway for current to flow, right? Moving from the negative terminal into the positive terminal of the power source, right? But in a parallel circuit, right, there is more than one pathway for electricity to flow, right? It has many branches, right? When you look at light bulb 1, it has its own branch. Light bulb 2 has its own branch also where current can flow. Are we together? Then light bulb 3 also has its own pathway where current can can flow. Are we together? And also in a series circuit, when you remove one component, the whole circuit dies out, right? The whole circuit becomes dark, or the whole circuit stops what? Working. But in a parallel circuit, when you remove one component, the rest of the circuit is able to work because each component has its own branch, right? So now let's quickly move on to our activity 2. Right. Number 1 says, what happens to the current strength when more resistors are added in parallel to a circuit? Number 2, what do you think will happen to the brightness of a light bulb if another light bulb is added in parallel? Then number 3, tabulate the differences between series and parallel circuits, right? Because now you still need to draw a table. I'm going to give you a full 5 minutes to complete this activity. Please don't forget our WhatsApp interactive number, right? So now let's meet after 5 minutes. Welcome back, grade 9s. Now let's look at the solutions together. Number 1, what happens to the current strength when more resistors are added in parallel to a circuit, right? So the current strength increases, right? It increases with more and more resistors added in parallel. The current strength increases. Number 2, what do you think will happen to the brightness of a light bulb if another light bulb is added in parallel, right? The brightness will not change, right? The brightness will not change. Number 3, tabulate the differences between series and parallel circuits, right? So let's move on to the next slide so that you can see the solutions. Right, in a series circuit, right, the same amount of current flows through all the components, whereas in a parallel circuit, the current flowing through each component combines to form the current flow through the source. In a series circuit as well, right, components are arranged in a line, whereas in a parallel circuit, the components are arranged parallel to each other. Then in a series circuit, remember, when resistors are put, the voltage across each resistor is different, even though the current flow is the same through all of them. Then in a parallel circuit, when resistors are put, the voltage across each of the resistors is the same, right? Even the polarities are the same. Then in a series circuit, if one component breaks down, the whole circuit will burn out. But in a parallel circuit, when one component is broken, the rest of the circuit will still operate because of what? Each component has its own independent circuit, right? So I'm going to give you 2 minutes to copy down these corrections. Then afterwards, we are going to continue with our lesson. Right, welcome back again, grade 9s. I hope you had enough time to copy down your corrections, right? So now, before we summarize today's lesson, let me give you a chance to comment, ask questions, or send in your answers to the previous activities on our WhatsApp number, which is 079 578 2908, right? And I'm going to give you 2 minutes tops to do so. Right, now this seems like there is no WhatsApp questions, comments, or anything regarding this lesson on our WhatsApp line, right? So we are simply going to summarize what we have learned for today. So today we're talking about parallel circuits, right? So we said that a parallel circuit is a circuit that has more than one pathway for the current to flow through, right? So there's two or more pathways for the current to flow through, right? And the voltage is the same across each component of the parallel circuit. And also we talked about what? The sum of the currents through each path is equal to the total current that flows from the source, right? So now, we also talked about the advantages of a parallel circuit connection, where we talked about what? There, we talked about that there is more than one pathway, so if one component is broken, the rest of the circuit can still operate, right? And you look at this, in this circuit, the current has access to this pathway for light bulb 1, right? And also there's access for this pathway, which is light bulb 2, right? So if you can switch off light bulb 1, light bulb 2 can still be on. When you switch off light bulb 2, light bulb 1 can still be on as well, right? And you said that our houses use parallel circuit connections because of such an advantage, right? Where you are able to switch on the lights in the sitting room and switch off the lights in the kitchen concurrently, right? Also now let's move on to our homework, right? Today we have a homework. It reads as follows: draw a parallel circuit with 2 light bulbs and 3 cells connected in parallel, right? So just take a quick minute to copy down this question. Then after that, we are going to say our goodbyes. Welcome back again, grade 9s. Now we are going to wrap up our lesson, right? But before that, let's look at what we are going to be talking about in the next lesson. So in the next lesson, we'll be talking about safety with electricity, right? All the safety precautions and all the hazards that may come with electricity, right? So you know what to do. Go home and study on this topic so that when we come back, it is an easy teaching and learning process, right? So from me to you now, thank you and goodbye.